Good afternoon to everyone. Welcome to the live interactive session for week 7 for the course on sustainable transportation systems. I'm Sedu Vinayaga, a PhD scholar in the civil engineering department at IIT Madras. Okay, so let's start with an overview of the contents that were there for week 7. Okay, so the first lecture of week 7, so we covered some of the what are the contemporary practices that are there in the transportation planning process, right? So we the end of week 6, finished with an introduction to sustainable transportation planning. Right? So we looked at the four-step process for transportation planning. So this week we continued with that, right? So we looked at some of the uh, processes that are involved in this transportation planning, and also we looked at some, issues, that are present in the or that has to be overcome in the transportation planning process. And towards the end we looked at different measures that are undertaken for achieving the sustainable transportation planning. So we looked at in particular some traffic calming measures, right? So these traffic calming measures, how do they help increase the safety and the efficiency of the transportation system, and the different measures that are coming under them. So we looked at that in the first lecture of week 7. So in the second lecture, so we looked at the other way of managing this transportation systems, that is through an approach called systems approach, or transportation systems management, right? So in this particular approach, we look at maximizing the use of the existing systems, right? So what are the strategies and techniques that are available through which, without expanding the transportation supply, how do we make use of the existing system to have the highest efficiency, right? So the different measures that are coming under this were covered in lecture number 2. And in the third lecture, so we moved on to the concept of life cycle analysis, or LCA, right? So here we try to quantify the impact on the environment, of a product or a service, or a process in throughout the life cycle of it, right? So what are the different objectives of life cycle analysis, right? So there are 3 to 4 objectives that were discussed. And what is the concept of system boundary, right? So basically, so when you say a life cycle of a process or a product, now there are different stages that are involved. So what are the phases or the stages that are being considered for this analysis, so that will define the boundary of the system, right? And then the system will be studied. And that there are different stages in the LCA as well, and there are 4 broad stages that we looked at. And then this lecture finished with the life cycle inventory and impact assessment. And in the fourth lecture, so we looked at the different ISO standards that are given for conducting LCA, right? So the different standards talk about different phases or stages. They give the specifications for conducting the LCA. And we looked at 3 different types of LCA, and then finished with a case study on electric vehicles in Italy. And the fifth lecture was also another case study for LCA, but this was for a biomass based energy system in Denmark, right? So this was the concepts covered in week 7. Now let's move on to some questions related to these. So the first question is, life cycle assessment is a form of environmental impact assessment, right? So we have to say whether the statement is true or false. Okay, like usual, we'll have polls. Okay, the poll is launched. So whenever you are ready, you can answer in the poll. Okay, so we have a poll going on for every question. So when you're ready, you can put your answer in the poll and then we'll discuss. Any answers? Okay, so we have one vote for option A. Okay, any other answers? All right, so let's take a look at the right answer. So the right answer is option A. The given statement is true. Right, so the LCA is one form of the environmental impact assessment. Right, so we covered in detail about environmental impact assessment in earlier week, right, around week 4 or week 5. Right, so this LCA is one way in which we can conduct the environmental impact assessment. Right, so basically it's a systematic analysis of the environmental impact over the course of the entire life cycle. Right, so as the name suggests, so this is from the start of the process to the end of its life. Right, so basically it could be from the start of mining for the raw materials till the disposing the product. Right, so it could be from the start to the end. So that's the life cycle analysis, and from each stage we measure what is the impact on the environment, and therefore we get a systematic or a holistic view of what is the cost that we are paying for the environmental impact. Right, so that's the LCA. Therefore this is one form in which we can assess the environmental impact. Right, so this models environmental implications of many interacting systems that make up the industrial production. Right, so we do not look at just the process that we are interested in, and also we see what are the other aspects that are interacting with this. Right, so we have to take everything into consideration and come up with a complete a model of the impacts that we are making on the environmental systems. Right, so that's the LCA. Okay, so therefore the given statement was correct. So question number 2 is, which one of the following is not a strategy for transportation system management? So option A is discouraging carpooling. Option B, internal shuttle in the city center. Option C, exclusive bus lanes. And option D, carbon pricing. Any answer? We have one more for option D, card and pricing. Any other answers? All right. So let's take a look at the right option. So the right option is option A. It is discouraging carpooling. Okay, so question is, which is not a strategy for the transportation system management, right? So as I was saying in the overview, so we looked at two broad, ways of achieving or doing this systems planning. So one is with the traffic calming measures. The other is through managing the existing system efficiently, which comes under the traffic transportation system management, right? So under these, we looked at different options of doing that. So a variety of strategies were discussed under the systems management, right? So given here are these some of these different strategies. One is carpooling, other is internal providing internal shuttles in the city center area, then exclusive bus lanes and cordon pricing. Cordon pricing is also maybe known as congestion pricing, right? So here we have to see which will enhance the sustainability, right? So carpooling, so what is the objective of it? So carpooling is basically instead of if say let us say four people are four people from four different households are going starting from the same origin and going to the same destination, right? So maybe at the same time or around the same time. So if they are not carpooling, they will be having their own individual vehicles and then traveling with that, right? So which means that four people will be using four vehicles to travel between the same locations at the same time, right? So that's not an efficient way of doing that. So instead, what can happen is if they can collaborate and then use the same vehicle, say maybe take one car because they are going to the same place, so they can all these four people can travel in the same car and then complete their activity, right? So this is carpooling. So what this does, it immediately reduces the number of vehicles on the road, right? So it again, it's not possible in all the cases, right? But when it is possible, when it is conducive to that, so it can be encouraged, and therefore carpooling will help in improving the traffic of the traffic congestion in the city. Therefore it should be encouraged, but the option A says it should be discouraged, right? So therefore this is not a correct strategy, right? Therefore that was the right option. This was not. Whereas the other ones, in providing internal shuttle in the city, so how will that improve? So internal shuttle means like providing frequent like a bus service to the city center, maybe to a radius of 3-4 kilometers from the center of the city. If you provide frequent bus service to the city center, then people may park their vehicles outside the city center and then use these shuttle systems to travel to the city center. So again, this will reduce the congestion in the center city center where you'll usually find a lot of traffic, right? So therefore this is a good strategy. C is providing exclusive bus lanes. Again, by providing exclusive bus lanes, you will improve the attractiveness of the buses because they will not be interacting with the other traffic in the streets, right? So therefore there will be more they'll travel more, their travel times will be more reliable, right? And therefore they will not get stuck in the traffic, and you can reach your destinations on time by using bus. Therefore people will be more incentivized to use buses when we are providing bus lanes, right? So therefore C is also a good option. D, cordon pricing. So what happens in cordon pricing? So for the heavily congested stretches or gardens or corridors, what you will do during the peak hours, we will put a heavy toll or so that people will not be using those routes, right? So when you charge a heavy tax, then people will be choosing alternate routes, right? Especially around the CBD area. So where there will be huge traffic, especially in the peak hours, so you implement this cordon pricing, then people will be less encouraged to use those roads, therefore reducing the congestion in those areas, right? So therefore D is also a good strategy for systems management. So out of the four, A is the only one which is not a good strategy for transportation system management, therefore the right option is A. Okay, question number three is the guidance on conducting the life cycle assessment, impact assessment, LCIA, phase of LCA pertains to dash. So option A is ISO 14041, option B is 14042, C 14043, and D 14044. Okay, so we have one vote for option B. Any other answers? All right. So the right option is option B. It is ISO 14042. Right. So in the fourth lecture, we are looking at the different ISO standards pertaining to the LCA approach. Right. So we have different standards looking at different phases of the LCA. So ISO 14040. This is the most like the comprehensive. Like it looks at the LCA as a whole. Right. So it's like an overarching standard. So this talks about or gives it talks about the general principles, the frameworks, and what are the requirements for different products and services. So whereas the other standards, so 4041, so it talks about the life cycle inventory and how to determine the goals and scope of an LCA study, whereas 14042 is for the LCIA, and then 14043 is for interpretation of the results. Right, so these are the different standards pertaining to LCA and different phases. And the question was about LCIA, which is covered in 14042. Therefore, the right option is B. So, question number four is which of the following is not an objective of life cycle assessment? Option A is product improvement. Option B is product cost reduction. Option C, decision making. And option D, environmental planning. One vote for option B. Any other answer? All right. So the right option is option B. It is product cost reduction. Okay. So there we looked at different objectives of LCA, right? So one of the objective is product improvement. So what is product improvement? It is basically looking at the different parts or the different processes that are involved in the product making, and then looking for an opportunity to improve the environmental or reduce the environmental impact at different stages, right? So that way we will be reducing the environmental impact of the product, right? So therefore that's the product improvement that we are talking about, and that's one of the objectives of doing the LCA, to know where there is a huge impact and how we can reduce it, right? So therefore A is one of the objectives. And C, in decision making, like for example, if you want to implement a scheme or a policy, how will it affect the environment, right? So what impacts that is going to have, or how it's going to improve the current situation. So those can be assessed, and that will help us make a decision whether we have to go forward with that option or not, right? So therefore it helps in making those decisions based on the environmental the aspects related to that. And D is environmental planning. So in environmental planning, so we are looking at how to assess or how to measure the impact on the environment. So to do that, we need to have some kind of indicators or variables that are measurable, right? So we'll have multiple options. So in doing that, by doing this LCA, we'll be able to find out which is more reasonable or more accurately measure helps in measuring this impact. So it helps us choose those indicators that helps us in making this assessment. So therefore it helps in the environmental planning as well. So that's one of the objectives. Whereas product cost reduction is not an objective of LCA, because we are not the objective, or the intention is not to make the product cheaper. It's more about assessing the environmental impacts only, right? So therefore the cost reduction is not one of the objectives of LCA. It's only to do with the environmental aspect of the making the product, right? So therefore B is not one of the objectives, therefore B is the right option. Okay, question number 5 is, prohibiting the right or left turning movements of vehicles is a strategy used for transportation management. So whether the statement is correct or incorrect. Okay, so we have one vote for option A. Okay, any other answer? Okay, so the right option is option A, that the given statement is true, right? So among the different strategies, prohibiting the turning movements is also one of the strategy that could be employed, as part of the transportation system management. right? So how will that help in mitigating the congestion? So what happens at the intersection? So you'll have generally requirements of people. Some people will want to move through, that is go through the intersection straight, and some people want to turn left, some people want to turn right, right? So all these different movements are possible, right? So what happens, but when you have a lot of turning movements, left turning and right turnings, that will actually slow down the number of vehicles that are able to pass through the intersection in a given period of time, right? So when you have only vehicles that are going through, versus when you have some vehicles going through and some vehicles turning left or right. So if you compare these two, when there is turning movements, there will be only fewer number of vehicles that can be served in a given period, right? So therefore, if the intersection is already having lower capacity and there is a huge demand that is coming into the intersection, and when you have a lot of turning movements, so that is going to severely impact the the flow rates, right? So therefore, what you do is you restrict the turning moments, right? So that only the straight moments are allowed. So by doing that, so we will improve the saturation flow rate of this intersection, right? So but if we are going to prohibit these moments, but we have to provide alternatives, right? So we cannot just cut down this turning moments. So some of the alternatives that we will provide is through these other types of movements like T turn, G turn, or Q turn. So which is like directing them to a another intersection which has a higher capacity and which can handle more turning movements. So those intersections are used for providing these alternate movements, right? So in a T-turn, what we will do, so when people want to turn right and they are diverted, so they will be diverted to another intersection, maybe ahead or ahead of this current intersection that they want to turn, and there they will make another turn and then come back to this place where they initially wanted, and then will make the movement that they were originally intending, right? So that's a T turn. And G turn, so instead of making the right turn at a particular intersection, so if these people will be diverted even before they reach this particular intersection. Whereas in Q turn, they will be diverted after the intersection, so they have to travel a little longer and then will be making this turn, right? So that's a Q turn. So these other movements can be accommodated to reduce the congestion at a particular intersection, right? So this is one of the strategies that could be adopted. Okay, question number 6 is, which one of the following options is not involved in LCA based product marketing? So options are environmental claim, user friendly, eco labeling, and product declaration. We have one vote for option B, user friendly. Any other answer? Okay, so the right option is option B. It is user friendly, right? So marketing is one of the objectives of LCA, right? So when we conduct LCA, so you have the total impact, a comprehensive or a holistic approach you have followed and come up with the total impact on the environment, right? So throughout the life cycle of the product, so you can use those results, for marketing a product. For example, you can have an environmental claim, right? So you will say that this product has this much or this only this many percentage of CO2 that is being emitted compared to other competitive products or so on. So you can have some claims like that related to the environmental aspect. You can use that to do eco labeling, like it is free of these things, and or you can use that for product declarations, right? So all these things can be used for marketing purposes as well, so that this LCAs can be used in that aspect as well. Whereas the option B says it's user friendly. So user friendly is not coming from the environmental impact. It's more to do with how the product is designed and so on. So that determines the user friendliness. How easy it is for people to use that product. So that's not coming out of LCA, right? So it's only to do with the environmental impact. Therefore, the user friendliness is not an objective, especially for marketing purposes. Therefore, the right option is B. Okay, question number 7 is walking as a transport mode has minimum negative impact on the environment. So option A is true, option B is false. Okay, we have one vote for true. Okay, so the right option is option A. It is true. Okay, so we are talking about walking as a transport mode, right? And whether it has negative impacts on the environment or not, right? So when we talk about negative impact, especially the environmental impact, so what are the negative environmental impacts? So these are, it could be noise pollution, increased fossil fuel usage, or air pollution, soil pollution, and so on, right? So when we are talking about walking, so we know walking is a non-motorized form of transport, right? So we are not using any of these the negative impacts that I was talking about. So those are not associated with walking, right? So there is no air pollution that is involved with it. There is no noise pollution. There is no fossil fuel usage and so on. So therefore, this has least negative impact on the environment, right? Among all the different modes that we know of, right? So walking is one of the best forms, right? So it's not possible to walk longer distances, but surely if we plan it correctly, plan the transportation modes and also the land use accordingly, so walking can be encouraged for carrying most of the regular activities, right? So therefore walking will help in more sustainable achieving a more sustainable transportation system. So therefore the given statement is correct. Okay, question number 8. is which of the following is also known as a raised crosswalk if placed at a pedestrian crossing? So options are speed humps, speed table, speed bumps, and bulb out. Okay, so we have one vote for B. Okay, so let's take a look at the answer. So the right answer is option B. It is speed table. Okay, so so we looked at these come under the traffic calming measures. So we looked at different categories even within that. So one of them is vertical deflection. Then there are lateral shifts, narrowed roadways, and also reducing the cut through movements. Right. So these were the different types under the traffic calming measures. Right. So these three come under the vertical deflection approach. It's where we are trying to increase the level of the road at a particular point so that the speed is reduced, right? So because people there'll be jerks if people travel at high speed over these raised pavement locations. So they'll experience jerk, therefore they will reduce the speed, right? And we have different types under that. So we have speed humps, speed table, and speed bumps. So these three they serve the same purpose. They basically differ and based on the dimensions, right? So when we look at speed humps, so these will be over a longer. They'll have a wider. They'll be the rising will be over a wider area, right? And then they'll be raised for a feet or two, right? But their horizontal or the lateral dimension would be much higher, like around 8 feet or so. Whereas speed table, they are much wider than the speed humps, right? And they'll have a flat top, right? So that is a speed table. And in speed bumps, we'll have similar to humps, but over a smaller lateral dimension, right? So there'll be it's much steeper vertical rising, right? That's a speed bump. Therefore there'll be the speed reduction due to speed bumps will be much higher than the speed humps, right? So because the speed table have a flatter top, right, and also wider than the speed humps and speed bumps, so sometimes they can be used for providing pedestrian crossing as well, right? So because they are also raised, they will be at the level of the sidewalk or the footpath, right? So therefore it is easier for pedestrians to shift from the crosswalk onto the speed table to cross to the other side of the road, right? So sometimes the speed tables are used for that, and when it is used like that, it is also called as a raised crosswalk, right? So therefore the right option is option B, it is speed table. Okay, question number 9 is well to wheel is a type of system boundary for the life cycle assessment. So we have to say whether the statement is true or false. Yeah, we have one vote for option A. Okay, any other answers? All right. So the right answer is option A, that the given statement is true. Right. So well to wheel is one of the system boundaries of LCA. Right. So where this particular system boundary is used. So it's particularly in the life cycle assessment of transport fuels and vehicles, right? So in this case, so we have, first we start with the feedstock production, right, where the raw material is, extracted. Then this is transported or distributed to the fuel processing, units, right? So this has to be processed, but not at the place of extraction of the the raw or the crude feedstock. So it has to be transported, so there is some emissions and impacts on the environment associated with this transportation as well, right? So this also has to be taken into account, and then it goes into the fuel processing stage, and then once the processed fuel is ready, so that processed fuel has to be transported to the pumping stations where it will be used, right? So if you look at it, when you consider all the inputs and outputs coming in this feedstock production up to the final transportation and distribution, that is called well to pump, right? So if your system is only from here to here, it is called well to pump. But if you consider the final portion, which is the end users, the vehicles that are using these processed fuel, so then in that case it will be well up to wheels, right? So it is the well to wheel, that is a complete the life cycle assessment of the transportation fuels, right? So therefore this is one of the system boundaries that is used in the LCA, right? So by doing this, you will be able to assess what is the total greenhouse gas emissions and what is the total energy usage. Again, you can do it by different fuel types, right? So therefore this is one of the system boundaries that we have looked at for LCA. Okay, question number 10 is vertical obstruction in the form of a rounded and raised area of pavement is known as dash. So options are speed table, speed humps, bulb out, and speed curb. Okay, so we have one option as option B, speed humps. Okay, any other answers? Okay, so the right option is option B. It is speed humps. Okay, so we already looked at the different forms of the traffic calming measures. So I said the speed table, speed humps, and also speed bumps comes under the vertical deflection or the vertical obstruction, right? So as we discussed about the speed table earlier, it is not having a rounded top, right? So it will be having a incline and then a flat top and then again another incline, right? So therefore the top of the speed table will be flatter, right? So it won't be rounded. So therefore A is not correct. Whereas speed humps and speed bumps, as we discussed earlier, so they will be having a rounded top, right? So they are not flat at the top, and the difference between the hump and the bump is, how, over what, length is this vertical deflection spread over, right? Speed humps will be wider, whereas speed bumps will be spread over a narrow width, therefore they'll be more steeper, right? So therefore humps and bumps will have a rounded top, so here only humps is provided, therefore that is the right option. It is rounded and raised area of the pavement, right? So whereas bulb out is not a form of the vertical obstruction, it is a technique for reducing the road width, right? So that's also can reduce the speed, but it is not through vertical obstruction, right? So there we did not look at anything like a speed curve, right? So the right option is speed humps. Okay, question number 11 is the contemporary transport planning process ensures sustainable development by emphasizing more on accessibility in comparison to mobility. So whether the statement given here is true or false has to be determined. So we have one vote for option E. All right. So the right option is option A, that the given statement is true. Right. So we are talking about the contemporary planning process, right? So what we are doing, presently to ensure a sustainable development. So we have these two aspects of accessibility and mobility, right? So mobility is more to do with, how make being able to get to a particular location, right? So more people can go through or more vehicles are able to travel, so you'll have higher mobility, right? So that was the older way of thinking, is to be making more vehicles to be able to move from one location to the other. So that was the focus. So if that was the focus, so what would happen is you will be providing more you'll be trying to improve or increase the capacity of the system, right? So you'll be providing more roads and so on. So that's how you increase the mobility. So what that does is, in turn, it will induce more demand, right? So as we have seen, by providing more and more supply, so you'll be catering to the present demand, but that will also increase the demand in the future for people to use more and more personal vehicles, right? So that is not a way of achieving sustainable transport system. So whereas on the other way, the other aspect is accessibility, which is how convenient or how easy is for people to reach a particular destination, right? So you make it more, if you make a location more accessible, it means that people are more easily or more conveniently they're able to reach that location, right? So if you plan your systems well, we looked at the different approaches, we looked at transit oriented development and so on, how we can plan the land use, and also how transportation system can be also planned together with the land use to encourage people to use a public transit system more than the private systems, right? So when you plan it in such a way, your the different activities are more accessible by using your public transportation rather than going with your personal vehicles. So if you are planning it in that way, then in that case you'll still be providing people with mobility, but also in a more accessible way, right? So therefore, people will be more encouraged to use your public transit systems than going with their private vehicles. Therefore, this is more sustainable way when we think about in terms of accessibility rather than just about mobility, right? So that's the current way of thinking to ensure that we have a sustainable development. So therefore, the given statement is correct. Okay, question number 12 is, a lane of traffic made exclusively for peak hour traffic in one direction is called dash. So the options are contra flow lane, diamond lane, high occupancy vehicle lane, and reserve lane. Okay, so we have one more for A, contra flow lane. Okay, any other answers? Okay. So the right option is option A. It is the contra flow lane. Okay, so generally, what we are used to seeing is the lanes with fixed direction of flow, right? So generally, you'll have roads, which will be divided into multiple lanes, and then the direction of flow along these lanes will be fixed regardless of the time of day. Always one lane will be used for only one direction of flow, and this does not change. That's what it is commonly seen. But there is also one strategy that could be adopted, is that is the contra flow lane. So as we see in this picture, there are three lanes for going from north to south, and there are another three lanes, but at a particular period of time, so some maybe in the morning peak, So we'll have a higher demand, from north to south. So in this direction, we have a higher demand compared to the opposite direction of flow. So what is done here is this particular lane. This is also this is a contra flow lane where instead of going from south to north, this north to south movement is allowed, and this is also coupled with only for buses, right? So buses are able to use this lane in the peak direction to go from north to south, and once the peak hour is over, this lane will again be converted, and the traffic will be allowed to move from south to north. So depending on the demand, this lane's direction of flow is adjusted, right? So this will increase the capacity of the road temporarily in the other directions, therefore the more demand can be served, right? So here, what how is this helping? So here we are making use of the existing roadway, right? So this was the length of the roadway. We are not adding any additional lanes, right? So we are not constructing any new road, we are not extending it, but making use of the existing system in a more efficient way, right? So the demand imbalance that is there on either direction, that has been utilized, to make use of this contra flow lane. Okay, therefore, this is the right option, option A, where we are making a lane exclusively for peak hour traffic in one direction. Okay, so once the peak hour is over, this direction will again be reversed. Okay, question number 13 is, which one of the following is not an example of prohibited right or left turning movements? Options are T turn, Y turn, G turn, and Q turn. Okay, so here one vote for option B, Q turn. Okay, any other answers? Okay, so let's take a look at the right answer. The right answer is option B. It is Y turn. Okay, so here which you are asking, which is not an example of prohibited right or left turn, right? So as we saw earlier, when we are prohibiting a right or left turn, so we have to provide with alternate options, right? So those are T, G, and Q, depending on how this prohibition is handled, right? So there is no Y turn for this prohibited right left turn, right? So what happens in a T turn? So suppose there is an intersection, right? Something like this, right? So, and suppose people want to you know, turn right. If people want to make this movement, at this particular intersection, then if this is restricted, so then what happens in a t-turn? So they will have to go to a different intersection. Or for example, let us take another example. So if people wanted to turn right from the south, and we want to restrict it. So in a T-turn, what we will do is, let them, go through, and let another intersection with a bigger capacity, handle this right turn. Okay, so they'll come here and they'll go this way, right? So instead of turning right at this particular intersection, so they are diverted to another intersection where they will make a turn, come back, and they will make this right turn. So that is a T turn. So whereas in a G turn, what happens is, when and suppose there is an intersection, right? So and suppose people wanted to make a turn here towards the right. So if this is blocked, what happens? Instead of turning, here, right in that intersection, at the intersection, much before that, so people will be diverted. So there's something like this, right? So to turn right here, so people are turned left at an earlier intersection, so they will go take this longer route, come back, and then go straight here, right? So the right turn at this intersection is restricted, and instead it is converted to a left turn at a previous intersection. That's a G turn. And similarly, there is a Q turn. So in Q turn, what will happen is, we'll take the same example here, right? So instead of so suppose people wanted to turn right here, okay, and we are going to restrict it. So what will happen? So they will be diverted to another intersection downstream, right? So where they will take a turn and then come back, right? So the difference between G and Q is, in G turn, they were diverted at an earlier intersection, whereas in Q turn, they are diverted at a later intersection. So they cross this intersection straight, go, and then come back, and then make the turn, right? So that's how these three different intersection prohibitions are handled. Okay. So there is no Y turn that we have looked at. So it is only T, G, and Q turns. Alright, so question number 14 is, the speed bump is an example of vertical reflection and traffic calming. So we have to say whether this is true or false. Okay, so we have one vote for A. It is true. Any other answers? All right, so the right option is A, it is true. Okay, so we already looked at the different traffic calming measures, right? So the vertical deflection is one of the categories of measures that we have for traffic calming. So traffic calming is basically reducing the the speed of the traffic. Okay, so vertical deflection, again within that we looked at three options. So one was the speed bump, right? So which is a round raised pavement. and the other was a speed hump, right? So which is similar to a speed bump, but it will just be over a wider area. And then we looked at speed table, right? So all these three come under vertical deflections. So speed bump is one of them. So the given statement is correct. Therefore, the right option is A. Okay, now question number 15 is product improvement and environmental planning or the applications of LCA. So whether the statement is true or false. Okay, we have one vote for A. It is true. Any other answers? All right. So the right option is option A, that the given statement is true. Okay, so we looked at four different objectives of the LCA, right? So these are two of them are product improvement and environmental planning. Right? So we also looked at marketing and also in decision making, where the LCA can be used, right? So in product improvement, we look for so since we are assessing every aspect of the product's life cycle, right? So we are looking at all the different stages and their impacts. So we look for opportunities where this product can be improved, in an environmentally friendly way, right? So where the impact can be reduced. So those can be come up. So those opportunities can be brought out through doing this LCA. So that helps in the product improvement, right? And also in environmental planning, as we said, so like in selecting the indicators that are helpful in measuring the or assessing the impacts. So those also can be brought out by doing the LCA. So these two are applications of conducting the life cycle analysis, right? So therefore, the given statement is correct. So question number 16 is which one of these is not a stage of the LCA process? So options are life cycle inventory, risk management, impact assessment, and interpretation. Okay, so we have one more for B. Any other answer? Okay, so the right option is option B. It is risk management. Right. So if you look at LCA, there are four broad stages or steps in it. So the first step is to define the goals and the scope of conducting the life cycle analysis. Next is to go for the life cycle inventory analysis. So this is basically like the data collection step, right? So all the different the inputs and the outputs of the different elements of the process or the product that we are analyzing, so all the data related to that has to be connected and documented. So that is in the inventory analysis stage. And third, once you have that, you go for quantifying the impact, right? So that is in the impact assessment, the third step. And finally, the interpretation, right? So you did the impact assessment, you got some results, so how do you make sense of it, right? So these are the four broad stages in the LCA process. So we do not have anything related to risk management, right? So, but if you compare it with the EAA that we have looked at earlier, so there we had one, defined step. So where we were looking at, this mitigation measures. So we come up with, or we foresee what are the different environmental impacts that can arise out of a particular project or a process, and then we come up also with some measures that we will take to manage those risks, right? So we had something like that in EAA, but we don't have anything like that in the LCA. Here it is more about just quantification and of the environmental impacts, right? So therefore we do not have risk management as one of the stages here. Okay, question number 17 is, which international organization for standardization ISO series explains the life cycle assessment procedure? So option A is ISO 17050 series, option B 16050, option C 15050, and option D 14040 series. Okay, so we have one vote for D. Any other answer? Okay, so the right option is option D. It is 14040 series, right? So we already looked at what are the different standards that are concerned about this LCA procedure, right? So we had 14040 up to 14043, like so for the different stages, whereas this 14040 is like the it talks about the LCA procedure, at a broader sense, that it gives the overall picture instead of focusing on any one particular stage. Right? So therefore, this out of these, 14040 is the one that's concerned about the LCA procedure. Okay, question number 18 is, in LCA, if the system boundary is from the extraction of raw material to the manufacturing of the product, then the type of the system boundary is called dash. So options are cradle to cradle, cradle to gate, cradle to grave, and gate to gate. So we have one vote for B, cradle to gate. Any other answers? Okay, so the right option is option B. It is cradle to gate, right? So we looked at these all these different types of the system boundaries, right? So what we call cradle to cradle is, so cradle is from, the extraction of the raw materials. That's where, uh, if you look at a particular product, so it needs some raw materials, right? So that's where the life cycle starts, right? So if that's your it's starting of your analysis point, the starting boundary, then we call that as cradle, right? So it is from the start. So once you have extracted it, so this raw material has to be go through a different process, and then it has to be, transported to the, factory or the manufacturing location, right? So when it enters this manufacturing location, so that is another critical point, so that is also called as the gate. Okay, and then within the manufacturing, once the product goes through the different steps in the manufacturing process, it gets produced, and then it will be ready for shipping, right? So that is another gate. So within the manufacturing unit, we have a gate at the start and then gate at the end, right? So when it enters and when it leaves the factory, right? So, and then again it will go through different distribution and transportation phases, and then finally it will go to the system user, end user, and then finally it will be disposed of, right? So that disposing stage is called as the grave, right? And then sometimes we can recycle the product, right? So once we dispose of, we can again recycle, and then use that for extract materials from that, and then use it again in producing the product. So that kind of a circular process is called cradle to cradle, right? So from the start again to disposal, and then bringing it back to into production, so that's called a cradle to cradle boundary. So cradle to gate is basically from the extraction till, if you go till the end of the production and before the distribution, so that is called cradle to gate, right? So cradle to grave is more more complete than cradle to gate. So instead of stopping at the end of production, you look at till the disposal of the product, right? So that's called cradle to grave. So whereas gate to gate, it is more restricted. So you're looking at only in the manufacturing part, right? So you're not concerned about the impacts in the extraction of raw material phase and the distribution and the transportation associated with that. So you only look at when the materials enter into the factory and when the product leaves the factory. So if you're only analyzing that particular portion, then it is called a gate to gate boundary, right? So whereas here we are talking about extraction of raw materials till the manufacturing of the product. So in which case we are looking from cradle up to the gate, right? So therefore the right option is B, right? So in the cradle to gate, we include all the processes from raw material extraction and all through the production phase, right? So till it leaves the factory, right? So that is the cradle to gate. Okay, so question number 19 is, which of the following is a strategy for transportation system management? Option A, internal shuttle in the city center, exclusive bus lane, cordon pricing, and all of these. Okay, we have one vote for D. Any other answer? Okay, so the right option is option D. It is all of these. Right, so we again looked at all these different measures, right? So transportation system management has a a bunch of strategies coming under it, so that can be used. So the earlier examples that we looked at, the prohibition of the turning movements, so those are also one of the strategies that we can use. So the others that are given here are also come under that. So internal shuttle in the city center, so as I explained it earlier, so we can provide frequent shuttle services to the city center, so that people will park their vehicles outside the city center and make use of these shuttle services, so which will have better or higher capacities than the private vehicles, right? The number of vehicles in the city center will reduce. Then providing exclusive bus lanes, again it will help encourage people to shift to public transit, especially buses. And then cordon pricing again reduces the congestion in the CBD areas, especially during the peak hours when these are implemented. Right, so all these three come under managing the existing system more efficiently, and therefore they come under the TSM strategies. So the right option is D. It is all of these. Okay, question number 20 is the spatial imprint in transportation planning varies with respect to the socio-economic and geographical characteristics of the city. So we have to say whether the statement is true or false. So we have one vote for A. Okay, any other answers? Okay, so the right option is A. It is true. Okay, so basically the spatial imprint is basically which if you look at the city as a whole, so which locations have what characteristics with respect to the traffic, where there is more private vehicles being used, where more public transportation is used, and those things. So we are looking at a spatial variation of these, uh, the traffic characteristics, and how we plan for that, right? So where we expect more private vehicles to be used, there will be more wider roads that will be providing more capacities to cater to it. And the other, where public transportation or where high, dense residential locations are located, so we may go for, planning or providing these high frequency, public transportation services, right? So we'll plan it according to these spatial variations, but that is dependent upon the socioeconomic and the geographical characteristics of the city, right? So based on the income levels and so on. So this variation will be seen across the city, and that will affect how the transportation planning is carried out. So therefore, the spatial imprint depends upon the socio-economic and the geographical characteristics. So the given statement is correct. So question number 21 is, what caused an increase in the traffic problems in the 1970s despite a great deal of urban planning? So the options are adopting a systems approach, planning based on the induced demand, encouraged use of alternative modes, and D, none of these. Okay, so we have one vote for D, none of these. Any other answers? Okay, so the right option is actually option B. It is doing planning based on induced demand. Okay, so here we are talking about, the approach that was taken for transportation planning in the 70s, right? So there was a great deal of urban planning, right? So which means how the land use will be used for the different purposes. But still, we had a lot of traffic problems because they were planning for the transport facilities. They were done adopting this, planning based on the induced demand. So what do we mean by this? Is we try to forecast what the demand is. Okay, so how many people, so you look at the current situations and then you forecast how many people will be using the system maybe in another 15 years, 20 years, and so on. And for that, that forecasted, the demand, to try to design your system to cater to that, right? So how it was done to take cater to the induced demand. So they were providing higher capacity facilities, right, in terms of the infrastructure that they were providing in terms of the roadways, right? So they provided wider roads, higher capacity roadways. So what that caused is it increased the demand even higher, right? So because the road facilities are good, so more than what they are expecting, so there will be even more number of people that will be trying to use their, the given facility because it is good, right? So therefore the demand is induced by the supply that is provided. right? So this is only going to worsen the situation, right? So you're expecting something, you're providing the solution, but that itself is going to increase the problems, right? So that was the approach that was adopted, right? So planning based on the induced demand. So whereas current the what is the contemporary approach, it is to do with the to go with the systems approach, where you are trying to make the best use of the existing facility, right? So that's where we looked at the different strategies on how to improve or how to cater to more people or more demand with the existing facilities, right? So you do not add more supply, you extract the most that you can out of the existing systems, right? And only once you are done with it, right? So once you cannot improve it any further with the existing system with all the different strategies, only then you'll go for increasing the capacity, right? So if that's a right way to do it, that's a systems approach. You look at the system as a whole, right? So if you're increasing the roadway in one corridor, that may reduce the congestion in that particular region, but it's going to attract people from other places, and therefore cause congestion in other locations, right? So that's looking at a specific corridor level, right? So rather, if you go for a systems approach, a more holistic way of looking at it, and adopt the different strategies, so you'll be better off, right? So therefore, so this was not done in the early periods. So rather, it was based on induced demand, so that created more problems rather than solving them. Whereas C, if alternative modes were encouraged, like going for public transit, so that would also reduce the problem, right? So because that will reduce the number of private vehicles that are there, so it will reduce the congestions, pollution, and so on. So that actually was not done in the 70s, right? So actually more people moved towards private vehicles. So the right option is B. Okay, question number 22 is what benefits is or are derived by reducing the car dependency? So the options are A. Improves accessibility to destinations by all modes, reduction in traffic levels, improves the safety on roads, and D. All of these. So we have one option, one vote for D. All of these. Okay, any other answer? Okay, so the right option is option D. It is all of these. Okay, here we are talking about reducing car dependency, which means that people are not dependent on their personal cars, for traveling to different destinations. So if car dependency is reduced, so what that will help in doing? So all the other modes will also be improved, right? So because the other facilities has to be improved, only then the car dependency will come down, right? So if, the buses and the trains, if they are running good, they provide convenient comfortable journeys, running at good frequencies, then only people will be moving from cars to these modes, right? So therefore what this does is improve the accessibility to all destinations by other modes, right? So all the other modes will also provide a better accessibility, so that will be one of the benefits that we'll be getting. Other is reduction in traffic levels, right? Because the number of private vehicles that are on the road will reduce, so basically we'll be improving the density, we'll be reducing the vehicular densities, right? So the in the given amount of space, more people can travel now, because this public transports can cater to a higher demand with a significantly lesser space compared to if private vehicles have to serve the same demand, right? So there will be significant reductions in the traffic levels on the roads, and safety will also be improved, right? So we have lesser congestions, lesser accidents will happen, right? So the safety will also be improved. So therefore, all these benefits will be derived by reducing the dependency on cars. Therefore, the right option is D. Okay, question number 23 is spatial imprint and the spatial interaction of the transportation depend upon dash. So the options are socioeconomic and geographical characteristics and the patterns of passenger and freight movement respectively. B is the opposite of that, the pattern of the passenger and freight movement and socioeconomic and geographical characteristics, respectively. And C is only the socioeconomic and geographical characteristics, and D is only the pattern of the passenger and the freight movement. Okay, so we have one vote for B. Any other answers? Okay, so the right option is option A, the socioeconomic and geographical characteristics and the patterns of passenger and freight movements respectively, right? So we already looked at what the spatial imprint of the transportation, planning depends upon, right? So we saw that it depended upon the socioeconomic and geographic characteristics. So that will directly eliminate option D as well as option B, because here the order matters. So we are saying what affect the spatial imprint and spatial interaction. B says the opposite, right? So the socioeconomic and geographical characteristics for spatial interaction and the pattern of passenger and freight movement for spatial imprint. But we know it is this part is for spatial imprint, right? So therefore B can also be eliminated. So it is between A and C that we have to decide, right? So what is this spatial interaction now? Spatial interaction basically means how the traffic movements happen. So we know that there are different in the demand for different activities will be different across different locations, right? So how will these different locations serve these different demands, right? So what is the movement of people between different zones, from where people want to move to where, right? So there will be work locations in particular zones, residential locations in particular zones, and then generally we'll have these movement between these work and the residential locations. And on holidays we'll have movement between residential locations and shopping centers and so on. So all these different spatial interactions, so they depend upon how this passenger and the freight movement occurs, right? So this pattern determines the spatial interaction of the different activities that takes place in the region, right? So therefore the right option is A, that the spatial imprint is dependent upon the socio-economic and geographical characteristic, whereas the interaction is dependent upon the pattern of the passenger and the freight movement, right? So therefore the right answer is given in A, so that is the correct option. Okay, question number 24 is which of the following is a demand based strategy So option A, carpooling. Option B, park and ride facility. Option C is congestion pricing, and option D, real-time travel information systems. Okay, so we have one vote for A, carpooling. Any other answer? Okay, so we'll take a look at the answer. The answer is option C. It is the congestion pricing. Okay, so here we are talking about which is a demand-based strategy. So which means, so which of these can be implemented or not implemented or adjusted, looking at the demand, right? So if there is a higher level of traffic, so you can do something. If there is a lower level of traffic, you can do something else, right? So which of these strategies provide that flexibility? Right? So if you look at these different options A, B, and C, so you'll observe that there is not much flexibility in adjusting this once these are implemented. So there is not much that we can do based on the demand. So for example, if you look at carpooling, so it's not really under the control of the system planner, right? So how people are going to get do this carpooling, it's not really under the control of the planner, right? So people decide to do that, they can do a carpool and then use it, right? So we can provide high occupancy lanes specifically for these carpool vehicles. But once you have given that facility, you cannot change that, right? So that lane is designated for carpool or high occupancy vehicles, right? So but whether people do that or not, so that's not up to us, right? So we cannot change it. So it's not based on the demand, right? So carpooling is not conducive to that. Again, park and ride facility. So what is it? You give this parking facilities at transit stations so that people will come park their personal vehicle there and then take the transit for the long distance journeys, right? So again, this is not a demand based strategy because these facilities are planned and designed and then provided beforehand, right? So based on the demand, you cannot adjust the parking facility, right? So these are also not flexible based on the demand. And real time travel information system, again, you provide this once the system is implemented, you provide the information all the time, right? So if lesser people are using, you're not going to stop providing the real-time information, or if more people are using, you're not going to stop the information, or so on, right? So this once implemented, real-time information will be provided all the time, right? It's not going to be changing because based on the demand. So the information may change, right? But this strategy of providing the information, that's not going to change, right? So again, this is not a demand-based strategy. Whereas congestion pricing, there is flexibility in adjusting that. How? When there is a higher demand, there is a lot of congestion, so you can go for this congestion pricing. Basically, you are going to collect toll or tax for using a particular corridor where there is going to be heavy congestion, right? So again, if you look at how this is implemented, so this will not be throughout the day, right? So during the peak hours when there is a lot of congestion, so you will be a lot of traffic coming in. So at that time, you will be implementing this policy, of collecting higher prices. Therefore, people will be less incentivized to use that particular stretch and then go for an alternative route. So once the demand goes down, particularly in the non peak hours, so you will remove your you will lift the pricing, right? So people can use that, without paying a heavy price, right? So therefore, based on the demand, you can adjust, how much you will collect or when you will implement this. All this can be decided in congestion pricing, right? So not in the other strategies that we have looked at. So this is more suitable or more flexible, and can be adjusted based on the demand of traffic that is coming in. So therefore, the right option is option C. Okay, question number 25 is, during peak hours, contraflow lanes improve the connectivity but degrade the lack of service. So you have to say whether this statement is true or false. Okay, so we have one vote for A. Any other answers? Okay, so the right option is option B, that the statement is false. Right? Because so we looked at when these contraflow lanes are used, or how they are used, right? So yeah, particularly you're looking at the peak hours, right? So what happens in peak hours? So we said that generally, in peak hours there will be an imbalanced, the demand based on the direction of flow. For example, in the peak hours, towards work locations, especially in the morning peak towards the work location, there will be a higher flow of traffic than in the opposite direction, right? So for example, let us say the work zone is here and the residential zone is here. So what happens in the morning peak, people will be moving towards the work zone from the residential zone, and there will be, in the opposite direction, there will be lesser traffic, relatively, right? So whereas if you look at the evening peak, the opposite will be true, right? So more traffic will be from the work zone to the residential zone and less towards the work zone, right? So there is this imbalance in the demand, or in the directional flow, right? So in that case, what happens when we are using the contra flow lanes? What are we doing? We are adding an additional lane, right? Effectively, we are adding an additional lane towards the peak direction of traffic, right? So from the opposite side, we convert the direction of flow to the other side, right? So therefore, the capacity is temporarily improved for one direction, right? So what is this doing? It is improving the connectivity, right? So more people are able to grow, but it is not degrading the level of service, right? So because we are increasing the capacity in the direction where there is higher traffic, right? So effectively the travel time will be reduced significantly, and the congestion will be reduced significantly in this peak direction of flow. While there will be some reduction in the capacity, it's not going to affect as much in the other direction, because the demand is relatively lower, right? So the improvement from this direction is going to offset any degradation that we may see in the other side. So overall, this is going to only improve the level of service as well as the connectivity. So both are improved. So therefore, the given statement is incorrect in saying that it will degrade the level of service, right? So therefore, the right option is false. Okay, any questions? Okay, so if there are no questions, we'll wind up the session for this week here. Thank you for attending. We'll meet again next week, Sunday, from 4 to 6 p.m. Thank you.